A very good day to my SV and also my panels. Please allow me to introduce myself. My name is Hussein, AN170233 from Cross BND Industrial Automation. The title of my PSM is Semi-Auto Dosing Robot with Image Processing. So this is my poster for my PSM, title Semi-Auto Dosing Robot with Image Processing. So in my poster basically included abstract, introduction, objective, methodology, conclusion, results and discussion, literature, as well as reference. So introduction, agriculture is an important sector in our Malaysia. So one of the main challenge faced by this sector in Malaysia is attributed to the low productivity and also the quality of our agricultural product due to the lacking of manpower. So by applying the semi-auto dosing robot with image processing, the productivity and the quality of Malaysia agricultural product can be increased. So in my PSM, there are two objectives. So one of it will be to develop a dosing robot for dosing after detected and identify certain crops by using image processing with the presence of the webcam on the robot. So the secondly will be to provide a safe, reliable, additive prototype and semi-automatic dosing system. Now I'm going to present about my flow chart of my PSM2. So basically, my robot is powered by a 24 DC power supply. So when the power supply energizes the microcontroller, the robot, the SADR-IP will start to approach to the crops. So when the robot is approached the crop, the webcam will start to detect the crop. So if the webcam didn't capture any crops, the robot will find the way to capture again. If there is something in front of the webcam, if chili is detected, the 45-degree button will be pressed by the owner or the user. So approximately 1 cube of water will be dosed to the chili. So if chili is not detected but tomato is detected, 45-degree button will be pressed by the user and approximately 1 cube of water will dose to the tomato. Lastly, if both of them is not detected but lactose is detected, 90-degree button is pressed by the user via Bluetooth. Approximately 2 cube of water will be dosed to the lactose due to a larger surface of the crops. So next, the whole process will take around 15 seconds for each crop. After finished dosing, the robot will wait for 15 seconds and start to approach to the next crop. So the process will repeat again and again and again until the user switch off the power. That's the flow chart of my project. Now I'm going to explain about how my image processing works in my project. So basically I have two different coding. One is the training coding and another one is the testing coding. So I'll start with the training coding. So from here, this part is basically the package that I need to install before I run my coding down here. So there are sklearn, CV2 NumPy OS and Keras, and most importantly is OpenCV. This is one of the main of the part in image processing I need to install. In this process, I face a lot of problems, hard difficult So I seek help from my SB and also some of my friends to help me solve it. So now I'm going to explain about my coding. So here is the parameters of my data, which I have collected some images from the groups. So here is some parameters for the pictures, the image, the pixel. So here I import the data or the image from the folder. I have total of 10 folder, which there are different types of groups inside. In my project, there are 3 specified groups, which are chili, lectures, and also tomato only. So these are the file name. So next I'll convert them to the NumPy, and I also split the data into different size, different type to test it. So next, after I have trained my image, there are a bar chart showing how the accuracy of my webcam is. The bar chart is in my thesis, or the technical report is shown in the technical report. So next, at last it will show the number of image of class of each image, class ID, and the number of class. So next, so here I'll start to train my image. Yeah, that's all for the training coding. So next I'll explain about the testing coding. So in testing coding, the package I use is NumPy, OpenCV, and also Picker. So in here I have set the parameters: weight 640, height 480. It shows the camera weight and height from the monitor of my laptop. So yeah, the 5 and 6 also the weight and height. So this model 3 crop is basically in the training program, I transfer the training program into the testing program, the coding, sorry. So these are all the predicts. So the most importantly is the class index. So for the chili is in file 7, so I change it to show it as chili as the output. The lectures will be 8 and 9 will be tomato. So I will test run for the training program. By the way, so since I have already trained the images, so the outcome will jump to the ending of the training process. So it mentioned, so the TensorFlow is one of the OpenCV is used in this image processing. So there are a total of 10 classes. So in here, there are the number of image for each class. So the testing program, I will not be testing here. It will be test on the next part of my video plan. So let's begin our demonstrations. So the robot is turned on and connect to Bluetooth Claw application via Bluetooth. In this, I use an Android phone to connect through Bluetooth. So the robot will stop for every 15 seconds for the purpose of identifying and also to dose the probe. So as you can see, chili is detected. So 45 degree of water is dosed to the chili. So as you can see from the bottom right side, is the terminal shows the chili and also the accuracy of the chili. So we need to wait for 15 seconds before approaching the next group. So the robot start moving and the tomato is detected, and the same 45 degree of water amount is dosed to the robot. Dosed to tomato. So as you can see from the top left side, the tomato is detected and also the accuracy is quite high. Need to wait for 15 seconds again before approaching the next group. So it start moving. So lastly the lactose is detected and 90 degree of the water amount is dosed to the lactose. As the same as you can see, the top left side, the lactose is detected on the terminal and it shows the quite high accuracy of detecting it. So basically the robot will keep repeating the same process for the next group after every 15 seconds. So for the conclusion of my PSM, the webcam is able to detect selected group with high accuracy at the monitor from far. The user can dose the correct amount of water via Bluetooth after correctly identifying the groups. So the overall system was functioning well. The semi-auto dosing robot with image processing could bring benefits to minimize the labor of the farmer, in addition to increase the speed and the accuracy of work. It can also reduce the amount of time of work spent on one group. Thanks for watching.